Good morning, everybody. We're going to give this about 30 more seconds and then we're going to get started. Okay. Good morning. Thank you for joining us for our webinar on pavement maintenance. John Rondinero is our instructor for the day. Polls will be done within Zoom. Some of the questions that appear may need to be answered in the Q&A, so definitely bring up your Q&A. I'm going to be sending out an email for you to contact for the handout. If you have not received the handout, look for that email address within the chat. Barbara will be sending that out if she hasn't yet. If you do have any questions, please put those into the Q&A and we will get those answered. And like I said, some of the poll questions will need to be answered in the Q&A as well. All right, John is going to be taking it over from here and he will handle any housekeeping items that we have. Have a great webinar, guys.
Excellent. Thanks, Jody. Good morning, everyone. Thanks for joining us here today. As Jody had mentioned, my name is John Rondinero. I'll be your tour guide for today's webinar covering common pavement maintenance techniques. Just as a little bit of background, I retired from DOT after 36 years. My last 15 years were as the head of materials engineering, where I had a heavy-duty involvement with all things pavement, pavement engineering, pavement maintenance, pavement materials, covered all those for the department. And now I'm into my 5th year working with Cornell, and I'm teaching both the pavement maintenance and the asphalt paving classes and webinars. Oh, hang on one second. Technical glitch right off the bat. There we go. All right, today we're going to be covering 3 of the most common categories of maintenance techniques: crack repairs, patching, and wearing courses. But before we jump into it, as Jody mentioned, I just want to touch on a couple housekeeping items. You've got your Zoom bar at the bottom of it should be at the bottom of your screen. As Jody mentioned, the chat is disabled. We'll be putting handouts or any other relevant information in there. Any questions you may have, put into the Q&A, and in some cases, we'll be asking you to raise your hand in response to some questions. And as Jody mentioned, we'll also be doing a couple Zoom polls. In terms of PDHs, this is worth 1 PDH in New York State. However, only the person registered can get credit for the PDH. It counts as a course. If for some reason, if you're from another state and you do want the PDH, you're going to have to check with your LTAP center. So let's do our first Zoom poll. Jody's going to throw that up on the screen, and just looking for an idea of where everybody is, everybody's working, who everybody is working for. I myself am working for the weekend. Jody, how are we looking?
I'm going to end it right now. It looks like majority are from the county, but we have some towns, some cities, some state, and some private.
Awesome. Great. Well, I appreciate everybody joining us. Jody, just threw the results up on the screen. All right. I'd like to just get a sense of what your job is, what your areas of responsibility are within your organization. And I'm an engineer.
Right, another few seconds. All right, the majority looks like engineers, but we have administration and some highway superintendents and board members.
Oh, fantastic. Glad to have everybody joining us today. Nice wide range of responsibilities. And just to get a sense of how long you've been in the business, See how long folks have been working in their current positions. I'm a 20+ year person.
All right. We have 11 to 20 years, 5 to 10. It's all across the board, pretty even here.
Excellent. Yeah, that's real good to see that nice wide range of experiences. And it's good to see that we got a bunch of us old timers. A lot of us with a lot of years under our belts. So glad to have everybody on board. And then just in the Q&A, if you'd let us know where you're from, it's good to get an idea of what parts of the state we're covering today.
We have Rockland County, Town of Cicero, Syracuse, Rochester, East Greenbush. Let's see if I can find some more, couple more from Rockland, Batavia, New York State, Rensselaer, Monroe, Albany, Suffolk, City of
That's
Canandaigua, Cornell, Steuben, so kind of all over.
awesome. Great. That's nice that we're covering the entire state. So great. Again, glad to have everybody joining us. So let's get into it. This is kind of what we're looking at in our business. This is a little bit more extreme version, but here's a pothole or a sinkhole that opened up on Jersey Interstate 80 in December, and it closed up traffic for quite some time. Took a lot of effort to get that baby repaired and get it opened back up to traffic. And this is kind of how it starts. We get a lot of precipitation, a lot of freeze thaw cycles. And this is what you start to see over time, even on a nice brand new pavement. If you're not taking care of it, you're going to start to see a lot of cracking. And this is what it can turn out to be, what it ends up being if you don't take care of business. And then back to our I-80 example again. They fixed the giant sinkhole on the shoulder in December, and another one opened up in February, about 50 yards away from it. So they had quite a this one in the center lane, and they had to shut down traffic again for a couple of days. Turned out to be quite a problem, and you really don't want to be facing that, especially on a major artery. And this is kind of what it feels like in our business. If you're wondering when that, if you're going to be able to stay ahead of that, that wall that could come crashing down on top of you. And I think it's kind of apt that we talk, we're looking at that giant wave because water kind of is one of our biggest challenges in our business. So let's talk a little bit about pavement basics. We all know the purpose of our roads. We're moving people and goods from point A to point B. It's the background of our economy. We use a process referred to as pavement management. That's our decision-making framework. And the steps within that process are you've got to inventory your roads and conditions. You then use that information to plan and perform the required work. And the key principles that you need to follow are right repair, right place, right time, and done the right way. Here's a standard pavement deterioration curve. You're starting up in the upper left-hand corner with a new or like new pavement. And over time, if you're not doing any taking care of business, not taking care of any problems on that pavement, it's going to deteriorate to a pretty much unusable condition. And that's the end of its life. And you can look at that same pavement deterioration curve and look at the different types of work that you can do over the life of that pavement. While that pavement's still in real good shape, you're doing your routine maintenance, work on your guide rail, your shoulders, mowing, any of that type of work. You're also doing your preventive maintenance activities, the stuff we're going to be talking about today, in particular your crack sealing and your thin wearing courses. Once it starts to deteriorate past that good condition, you're going to start to get into corrective maintenance. That's what we're talking about, our temporary patching and your single course overlays, shallow mill and fill. Then once you get past that, you're into your rehabilitation and reconstruction categories. Your pavements are in rough shape, and it's going to take a lot of work to get them back in good condition. So let's do a real quick poll. Pick A or B. What do you think is the most cost-effective way to keep your road in good shape? Applying pavement maintenance treatments while the roads are still in good condition, or waiting until the pavements have deteriorated to poor condition and then applying the more extensive rehab or reconstruction treatments? Jody, have we got some answers?
Yes, the majority are saying A.
Excellent. That means that we've been doing we're getting the message out. People are doing the right thing. Absolutely. Applying the pavement maintenance treatments on roads while they're still in good condition is what we need to be doing. And why do we need to be doing that? Well, if you wait until that pavement gets in poor condition, in tough condition, it's going to cost you 4 to 5 times as much as it would if you were treating it with maintenance treatments while that pavement is in good condition. So when we talk about pavement maintenance, we're talking about those inexpensive repairs on good roads that keep them in good shape. We're doing it primarily to maintain a safe travel environment. We're doing it to protect the public's investment. We're doing it to make best use of our limited resources and really to get the best bang for the buck. This is what we want our pavements to look like. Not like this. And we've got a pretty standardized process that we use to choose the repairs that are appropriate for the condition of the pavement. You've got to get out there, you've got to look at the pavement distresses, you've got to analyze the probable causes of those distresses. You're then going to look at the tools in the toolbox, evaluate your alternatives, and you're going to make a decision about what the most appropriate repair option is. And in this case, when you look at that picture, you gotta wonder what these guys were thinking. In terms of the tools in the toolbox, you've got two major categories. You've got your pavement maintenance, what we're talking about today, and then you've got your pavement rehab treatments. The one thing to remember about your maintenance treatments is they do not add or restore structural strength. Again, we're talking about our crack repairs, our patching activities, any kind of area repairs in our thin wearing courses. On the other side of the ledger, with our rehabs, they are going to add or restore structural strength because all pavements are going to eventually wear out and you're going to have to do some sort of rehab over the life of that pavement to restore it to a full functional condition. In terms of our distresses, when you're observing and inventorying them, you've got 4 major categories. You've got cracking, disintegration, surface defects, and surface deformations. And in terms of the specifics, we've got a whole bunch of different types of cracking. In particular, one of the ones we worry about or focus on the most is fatigue cracking, but longitudinal and transverse cracking are really the targets of our crack sealing efforts. Disintegration is when those cracks get too far away from you, and now you've got potholes and they require the patching work. Surface defects include raveling, bleeding, delamination, and polishing, all circumstances where you've got surface issues you're going to have to deal with. And then surface deformation, the big one you've got to worry about there is your rutting. And the key here is that you're going to identify the type of distress, and then you're going to be rating it in terms of extent and severity, high, medium, and low. And then the really underlying focus is you've got to assess the causes. You've got to be looking at your drainage, your soils, your trucks and traffic, all that loading that you're applying to the facility. You've also got to be looking at the environment, the weather, any underlying culverts, utilities, all those kind of things that could be a cause of your problems. In terms of the framework, then you're going to marry up the distress identification and analysis. You're going to marry that up with your tools in the toolbox, and you've got a pretty solid framework to be making treatment selection decisions. So one other thing that we've got to consider, we've mentioned it a little bit, but hasn't been really jumping out at us. Before we select a pavement treatment, what's the fundamental question we need to ask? And just put your answer in the Q&A. You got any
We have
answers?
answers coming in: cost, budget, money, condition of roadway, probable cause, the best condition, time, condition of the road.
Excellent, excellent answers, but not what I was looking for. The fundamental question that we've got to ask when we're doing this assessment is, how's the drainage? And this is a picture that was, well, I'm not discounting any of the answers. We've really got to know what's going on with the water. Because if we're not taking care of the water, no matter what work we do, it's gonna be pretty useless, because the water is gonna be doing nasty things to our pavements. And this is a picture that was shared with our director, David Orr. Gentleman Jay Olson was kind enough to share it with us, and I think his statement is pretty straight on. Drainage is critical for roadway design, and ducts are an indicator of poor drainage. In terms of tools, things to help us in our pavement maintenance workbook, the workbook that we offer or that we share when we're doing our workshops, I'd encourage everybody to get your hands on it. Whether or not you take the workshop, you can send a note into Jody, and we can get you either an electronic or a paper copy. On page table 4, page 34, nice little matrix. On the left-hand side are your tools in the toolbox, your treatments. Along the horizontal axis are your various treatments, and it just lays out when those treatments are appropriate. And real nice starting point. And as you can see, this is my copy. I got all kinds of notes, because as I work with it over time, I start to see little things that help me make better decisions. And this is what we're looking at, what we're looking for, and what we're looking at. This pavement's 2-3 years old. And you can see moisture on the surface. It's starting to look pockmarked, and that's a great indicator. It's time for some time to start thinking about preventive maintenance, some sort of preventive maintenance treatment. And then if you look at it a little closer, you can see those cracks that are starting to appear. You really want to get this on your radar for treatment within the next couple of years, because if you don't, it's going to start looking like this. Anybody think this is a good preventive maintenance candidate? Just show of hands real quick. Jody, how are we looking?
Give me just a second to get to that. Of course, I have way too many windows open. I can't.
Well, I'm going to jump ahead here. I would
Okay.
say maybe a couple years ago, or if the entire section was looking like this. But once it starts looking like this, not a good candidate. Starts to deteriorate even further and looking like this, definitely not a good candidate. You're well past the window of doing any kind of maintenance, preventive maintenance treatment. And in the end, you'd be looking at activities like this. This actually falls into our maintenance category. It's corrective maintenance. You're doing some temporary you're doing some patching to take care of the worst parts of it. So yeah, it falls into the maintenance category, but this thing is ready for rehab. So let's talk real quick about our first category of treatments, crack repairs. You'd find that in chapter 6, page 35 of the workbook. And real quick in the Q&A, why do we fill or seal cracks in the pavements? If you can throw some answers into the Q&A. Jody, we getting some answers?
Yep. Prevent water intrusion. To keep the water out is the majority of the answers.
And they are correct. That's exactly why you're filling and sealing cracks. You want to prevent or reduce that flow of water or debris into the pavement section, and therefore preventing or reducing the rate of deterioration. And a couple of the factors that you need to consider when you're doing that is the crack density. If you've got more than 1 or 2 cracks, you really can't be filling or sealing anymore. The level of edge deterioration, once that edge starts to fall apart, sealing and cracking really isn't effective. The width of the crack and the movement of the crack. And there's a nice table in the workbook that helps you choose what type of repair. Just looking at, if you've got a high level of crack density, meaning you got a lot of it, and you got a high level of high level of edge deterioration means it's severe. The severity is real high. You're looking at a rehabilitation category. You're no longer in the maintenance category. In terms of sealing versus filling, really there is a clear distinction. When you're sealing cracks, you're attacking your working cracks, which means they're moving greater than an eighth of an inch between the seasons. When you're filling cracks, those are your non-working cracks. They're not moving, so you can use a lesser material to fill them. And this is what a crack should look like. This is a perfect candidate for crack sealing. This one is getting right to the edge of whether it's a good candidate, but if you came in and cut or routed that crack, you could still make a crack sealing work, especially because you don't have any, interconnected or secondary cracking. Once your pavement looks like this, lots of secondary and interconnected cracking, you can't, crack sealing is not going to work for you. And then put on top of it, it's right in the wheel path. So this is a load related set of distresses, and your crack sealing is really not going to be helping you when you let it get this far along. This is definitely not a candidate for any sort of crack treatment. You really got to be doing something heavier at this point. The difference in materials when you're talking about filling and sealing, really, filling is a conventional material. It's a material that hasn't had any kind of additives or modifiers included with it. And on the sealing side, you've engineered that material, you've added a polymer typically, or some sort of rubberizing agent, and that's going to be giving you the ability to handle those moving cracks. Configurations are pretty standard. You can either flush fill it, you can overband it, and you can cut in a reservoir with some sort of cutting tool or router. And that's the preferred method. Is really when you're working with an engineered material, you want to give it a big channel to be working in. You definitely do not want your end product to look like this. Once you hit some moisture on that pond of crack sealer, it's going to turn into an ice skating rink, and it's going to be especially dangerous for anybody on two wheels. Motorcyclists hate it when they see it. In terms of construction operations, cutting, cleaning and drying, material installation, finishing and blotting, and in this case, we're routing in a crack prior to sealing activity. Cleaning and drying are critical. You typically got to get out there at least with an air compressor to blow them clean and dry. What's becoming much more popular, within the industry, is the use of a heat lance to clean and dry your crack. And the reason it's so critical is if you don't get it clean and dry, even if you're using an engineered material, you're going to be able to pull it right back out. And this is what a typical rig, tow behind rig would look like. And here's, the disc that you would be using to apply it. And then you've got a nice thin film of material, and under pressure, it's being, pushed deep into that cut crack. And then finishing it off, simple is better. You can take a squeegee, turn it into a V, push it along the placed material, and your end result is going to look. You want it to look just like this. Nice little, fingertip indentation that gives you. It's not quite at the surface, but it's going to give that material room to move as that pavement is moving during the change of the temperature. Blotting is not allowed. Was a practice at one point in time, but not allowed by DOT specs at least anymore. And then in terms of weather conditions, you want temperatures, decent temperatures, 40 and rising. Humidity is the enemy. You want 80% or less, and no chance of rain. At least a couple days before and a couple days after to make sure that your sealer has a chance to cure. So, quick PDH question: what's the most appropriate way to treat a working moving crack? Crack filling or crack sealing? And just throw it into the Q&A.
John, while those answers are coming in, we do have a question. What are your thoughts about crack sealing around large patch locations? And the answers are coming in for the question, and it's sealing, crack sealing. It's across the board: filling, crack sealing.
Yep, it is absolutely crack sealing. That's great. You're going to be using an engineered material that's going to move with the movement of that crack. So thank you. Excellent, Jody. In terms of sealing around a patch, let's talk about, remind me to go back to that when we get to, as we get through the patching discussion.
You got it.
Thank you. All right, and talking about patching. So everybody pays for potholes. And if you've left a muffler or a tire or worse in a pothole, you're not a very happy camper. And so just real quick, borrowed this from our colleagues at PennDOT, how a pothole forms. I think everybody understands this, but just touch on it real quick. You're getting water into the pavement section. While it's still, the temperatures are still, still allowing it to be liquid. Once those temperatures drop and that temperature drops within the pavement section, you're gonna freeze up that water. It's gonna create an ice lens. And like any ice cube, it's going to expand. It's going to push that pavement up and out. Then once the temperature drops or rises again, you're going to, and that ice lens melts, you're going to create a gap. That pavement is still now has been pushed in multiple directions. And then once you put any kind of loading on top of it, you're going to crush that. You're going to crush that pavement section, and you've created a pothole. And we've got a number of different patching types that we use to address our pothole problem. We've got our semi-permanent, our temporary patching, our spray patching, demand patching, and mastic patching. So in terms of semi-permanent area patching, that's what we're doing when the asphalt plants are open. We're cutting in our boundaries, we're removing the old material, we're cleaning or repairing the foundation, we're applying tack coat, we're filling the hole with the patch material, and we're cleaning it up. And just real quickly through this, marking out the boundaries, don't put in a lot of extra jogs. Cut a nice rectangle around that. The fewer jogs, the fewer weak points you have in your patch, because you're not able to compact, get full compaction in each one of those angled areas. And you don't want your patch looking like this. You put an awful lot of extra effort to save a little bit of material, and you've created a whole bunch of weak points. So you go in, you identify your distressed area, get about 6 to 12 inches outside of that distressed area. You identify your boundaries, you cut in your boundaries, and as you notice in the orange, your distressed area is actually back further than the visible edge of that pothole, and you need to get outside of that edge. Remove your materials. You can use all kinds of tools. In this case, a small milling machine. The only thing you don't want to be doing is going in there and trying to peel out your section with the edge of a backhoe, because all you're going to be doing is busting up your pavement. Get in there, clean and repair, and then apply your tack coat. And this is going back to our question about the patching. You've got to get the tack coat in, or a question about sealing around that edge. What's going to help you a lot is you've got to get the tack coat in here, and it is something that a lot of people still don't do. Then you've got to fill the hole. You got to make sure you've got 25% extra. That means you've got to have a 1/4 inch of extra material for every inch of compacted depth. And you're doing that because you've got to make up for compaction. And in this case, you think this tool is going to work? This vibratory tamper? Probably not. Sometimes you have to use it in a small hole, but you're going to have to go in with real thin lifts. This thing is really not going to give you any more than an inch of, an inch of, you're only going to be able to compact appropriately 1 to 2 inches of depth. And then you're going to clean up your finished patch. I'm a fan of sealing outside of the edges of those patches. Don't have to do it right away, but if you're not sealing that, if you're not getting back in and sealing any separation that's forming, you've just created you've created a localized ponding area. In terms of spray patching, a little bit of use in New York State, not a whole lot. What's nice about it is it's an all-in-one operation, and you've got a couple different types of equipment. You've got some towable equipment, You've got some automated patching equipment, self-contained unit. But again, we're not seeing a whole lot of it in New York State. Demand patching, our temporary patching, that's our bread and butter. And because it's our bread and butter, we're usually doing it in very poor conditions. So why do we do demand patching, pothole patching? Throw your answers in the Q&A if you would, please. And what are we seeing, Jody?
Nothing. Yeah. Oh, there we go. Unsafe conditions, safety hazards, necessity. Mostly it's about safety, peace of mind,
Yep,
and solves the immediate issue.
yep, perfect. Those are the answers. It is our most common pavement maintenance technique. We're doing it to restore safety. In some cases, it's we've established 24-hour standards for patching potholes in different jurisdictions. Big key here, the key here is that we want to be using what is called the throw and roll technique, using a modified patching material. In the old days, we were using the throw and go with conventional materials. Uh, it really doesn't work. And in all cases, the underlying distress is not repaired. You're going to have to come in and do a more permanent patch, but this gets you through the winter. And this is what the results of throw and go typically are. And this was shared by our director, David Orr, outside of Cornell. And three jurisdictions kind of have ownership of this section of road. And all three were using the throw and go, and all three ended up with the same results. They'd start with what's on the left, they throw some material in it, smack it with the top of the shovel, head down to the next set of holes, and they ended up with what's on the right every time. So not cost effective, not buying you any kind of good end result. What you want to be doing is using the throw and roll technique. Can sweep it out, get the water out of there, but not completely necessary. It'll still work, even if there's a little water in the hole. Throw your material in the hole, and if you look at that picture, you can see that material looks glossy and almost like it's compacting under its own weight, and that's the polymer that's mixed into that mix that's really starting to go to work. And what really makes it work is it's pressure activated. You hit it with that truck tire, so you're backing up over the material and then pulling forward. There's your end result. You've got your pothole patched, and that material is going to stay in that hole. And the only thing that I would add is I'd run over it one more time to knock down those high edges. But otherwise, you've got a good temporary patch in place that's should last you all season. And this is just a simulation that the folks at Cornell did. On the left, you've got your throw and roll. On your right is your throw and go. And if you look at that, towards the top of the slide, after 26 seconds, the throw and go material is already breaking down. And after 15 minutes to 25 minutes, the throw and roll material looks like it's even compacting under its own weight. So throw and go is the way to go. Throw and roll is the way to go. I even get myself mixed up trying to be a smart guy. All right, so if we've got a long section of roadway with large cracks over, an inch wide and very deep with high levels of edge deterioration, but you don't have enough money to do a pavement rehab project, what would you do? And I want you to pick one of these answers, put it in the Q&A. Would you do nothing? Would you cry, which would be my answer? Would you crack seal, or would you do something else? And what would you do? Put it in the Q&A. Now, remember, you don't have enough money to do a true pavement rehab project.
All right, John, we have patching, mastic, crack seal. Let's see what else. Patch, throw and roll. Mastic, backup shoulders, wait for more funding.
All good answers. I think the one you want to consider really, really strongly, though, is your hot pour mastic option. And there's a lot of use in New York, and it's continuing to grow. And for anybody that's not familiar with your mastics, it's a hot poured modified material. It's pre-mixed with a lightweight aggregate, and you can use this in places where you've got highly deteriorated pavements, where you've got large cracks over an inch wide and very deep. Those are areas that traditional crack sealing is not going to work, and in areas where you've got extensive alligator crack. Now, again, you're going to need clean and dry conditions, but you can apply when it's very cold. It's going to get discharged out of a melter unit, and you can pour it either directly into a hole or spread it over cracks using over your cracks using a drag box or a squeegee. And we're continuing to see national standards be developed and continuing to evolve. This is what cutaway would look like. On the left-hand side is the fine gradation. You can use that in a thin application, typically for treating alligator crack areas. And then on the right-hand side, you've got your coarse aggregate gradation, and that's what you'd be using when you're trying to fill in a big, big deep hole. So this is what your pavement issues would look like. Big deep hole. You get in there, you can get it filled up with mastic. And the beauty is because it comes mixed with pre-mixed with your aggregate, you don't have friction problems. That's what differentiates it a lot from your crack sealing is crack sealer doesn't have any aggregate in it. So any place that you've put down that sealer, you don't have the friction properties that are necessary to provide skid resistance. You can use it on concrete. You can use it for bridge deck repairs, and it'll bond to the steel and the concrete. It's really nifty. Comes out. It's almost like a ready mix unit. The melter unit pours it out the back of the chute, and then you can put it into a drag box. All kinds of different ways you can convey it. You can carry it in a bucket to your drag box. You've got little buggies that you can use for your crack filling or crack sealing or mastic sealing activities. Drag box is typically a pretty standard way of doing it. And you can also, when you're looking at your thin applications, pour it right out of the with your fine aggregate mix, pour it right out of the back of your chute, squeegee it in, and you've got a real nice treatment for any alligator crack areas. So what's next with mastics? There's still still a lot of room for growth. Every manufacturer's got their own specific technical requirements. There are some national standards being developed. And at this point right now, mastic is available under OGS contract. And if you haven't used it, I'd say take a look at it. It's a real nifty product. One of my favorites on the preventive maintenance side of the equation. And then getting into our home stretch, we'll talk about our thin wearing courses. So Jody, do we have any questions up to this point?
John, yes, we do have one. Is there a typical New York State DOT pay item for mastic material?
Yep, there would be, and I don't know it offhand, but you can just by scrolling through the spec book, you can find it, and you can also find it listed on the OGS contract. All right, so thin wearing courses. Why? Well, we want to seal and protect our pavements. We want to restore that skid resistance. We also want to be restoring any oxidized surfaces that have resulted from aging, weathering, any of those environmental factors. We can also use them for filling minor ruts, specific treatments, specifically microsurfacing. This pavement is a perfect candidate for a preventive maintenance thin wearing course treatment. The surface is uncracked. It's starting to show a salt and pepper look when it's just after moisture, after it's rained and there's moisture on the surface. That means moisture is being absorbed into the pavement section, and it's time to get a coat of paint on top. So our thin wearing courses, there's a whole bunch of them out there. Chip seals, which are emulsion-based, sand seals, which are the fine aggregate treatment. It's also emulsion-based. Slurry seals are an all-in-one emulsion-based treatment. Microsurfacing is slurry seal on steroids, so it's a polymer-based treatment. but again, it's emulsion-based. NovaChip is a specialty treatment, which is a combination or a hybrid of emulsion and overlay. And then our thin asphalt pavement overlays. We'll touch on each of them real quick. Chip seal, you've got your larger aggregate size, your coarse aggregates. And the key here is you've got your aggregate distributor close, or aggregate spreader close up tight to your liquid asphalt distributor. And one thing you want to notice here is your newly sprayed liquid asphalt is a rich brown, chocolate brown color. That's real important, and we'll talk about that in a second. Sand sealed, same thing, only you're using a fine aggregate, and again, you're looking at that emulsion being a nice rich chocolate brown. So, quick question: when we're applying an emulsion-based treatment like chip seal, you want the emulsion to be a deep black color before applying the aggregate. Is that true or false?
John, as the answers are coming in, majority are saying false. I
Good
do
answer.
have a statement from someone that said we typically broadcast some additional fine aggregate on the surface for longer longitudinal cracks. And again, everybody is saying false.
Great. I'm not quite sure I followed the question. I think that's probably one. Why don't let's have that person email that question in and we can get them an answer. All right, folks, everybody's right. That is false. You want that to be a nice chocolate brown color. Once it's turned black, that aggregate's no longer going to stick. So let's talk about our emulsions really quick. What are they? The tiny droplets of liquid asphalt that have been blended into water at high speed with an emulsifying agent. It's creating that suspension, so that's why you're getting that nice brown color. The emulsion is attracted to and bonds to, coats those aggregates, and once you're in contact with the pavement, that emulsion starts to break. That means the water is starting to separate from the asphalt and it's turning black. And so this is just a diagram to show the same thing. You've got that blended emulsion, the liquid asphalt blended with the water. Once it breaks, you've separated the water from the asphalt, and that means no longer you're going to be coating. You're no longer able to coat or adhere to that aggregate. And then once it's cured, that means that water's been evaporated away. And so if your liquid asphalt's looking like this during your process, it's not, your aggregate's not going to stick. Here's another case of it. And when you look closely at that picture, you can tell they're already pulling away. They know they're too late and they've got to figure out what they're going to do next. Slurry seal is an all-in-one unit, as I mentioned, puts down a nice thin coating of an emulsion-based treatment. Microsurfacing is polymer modified. Slurry seal, it's a little more sophisticated, gives you a really nice, really nice surface, and really one of my favorites, one of our best tools in the toolbox. And it's a particularly good treatment because you can be using it for rut fill. You can put a rig on the back end of the screed. You can channel the microsurfacing material into the rut, and as you can see in this picture, you can put down a couple courses. You can put down a couple sections of that rut fill treatment. You see that on the right hand side of the slide, and then on the left hand side of the slide, that's the finished product where you put a final course of your microsurfacing. NovaChip is a specialty treatment. As I mentioned, it's a combination. You're going to get it's almost like a chip seal on steroids. You're getting a single stone thickness. And the key here is you've got a all-in-one paver, single unit that has a built-in spray bar that applies a tack coat on steroids. And so you're putting down a nice thick coat of that material. You're applying your hot mix pavement your specialty hot mix pavement right on top of it. And it locks in real tight. That is true armor coating. Then last but not least, the tools in our toolbox, we'll talk about our thin asphalt pavement overlays. That's our 6-3 DOT mix, goes down about 3/4 of an inch to 3/4 of an inch to an inch. And all your good paving practices apply. You've got to have appropriate weather, your material temps, you've got to be using tack coat, you've got to be using joint adhesive, you've got to have proper joint construction, rolling patterns. All those things are important to get a successful project. And while we're talking about our asphalt paving activities, let's talk real quick about hot mix versus warm mix asphalt, and quick show of hands, who's used warm mix in the room? How are we looking there, Jody?
We are up to 9 participants that have raised their hand. Oh, 10.
Okay, so a handful, not, not as many as I would have expected. So this will be a good use of our time. It's the difference between hot mix and warm mix is what you'd expect. On the left-hand side, hot mix is being produced at very high temperatures, and that's why you're seeing the steam coming off the top of the load. On the left-hand side, on the right-hand side, as it's being dumped out, much warmer, being produced at much warmer or cooler temperatures, you're not going to be seeing that steam. And what we're talking about is, when we're talking about warm mixes, you're producing at 275 and lower, whereas our typical hot mix is over 300. And that becomes real important. You're seeing this is some pictures that our industry friends have shared with us. Here's hot mix going down at 320, steam's pouring off of the top of it. That's a tough set of conditions to work in. Warm mix going down to 245, a lot better set of conditions for our workers. Lots of benefits from warm mix. Lower fumes and emissions, lower energy, better worker environment, lower plant wear for the producers, increased workability, decreased aging, early ability to open your site quicker because you're working at lower temperatures, you can get traffic on quicker. And in some cases, some states and Canadian provinces are doing cooler weather paving using warm mix. Why is this important? Where are we today? Well, in New York State, on DOT projects, throughway projects, anything that's using a state DOT spec, you're 100% warm mix. There is no such thing as a 402 item, hot mix item anymore. And as far as we're concerned, as far as DOT concerned, warm mix is the same as hot mix. You're just producing and placing at lower temperatures. There's a very good chance you're going to be seeing warm mix, whether it's this season or upcoming seasons. We're at about 25% of the material that's produced in the state now is warm mix. And you're going to be seeing more and more as adoption continues to grow. One key, though, you've got to closely coordinate with your producer regarding your paving practices, and especially your rolling temps, because per the DOT spec, you can't be higher than 295 at the paver, and you've got to complete your breakdown rolling on the mat by the time you get to 230. And that is different than what we're looking at when we're working with hot mix. So the bottom line, talk to your producer regarding any kind of asphalt mix you're using. You really want to know whether you're using hot mix or warm mix, because it's going to make a difference regardless of the type of work you're doing, whether it's overlays, paver patching, hot box patching, all those kind of things. And then what else is coming? What's coming down the pipe? Increased use of warm mix. You're going to see a lot more of it. We're going to continue that is going to continue to be the, it's going to become the standard in New York State. We're going to start to see performance engineers mixed, where you're picking different performance criteria, such as cracking and rutting resistance, and you're going to be engineering your mix specific to address those distresses. Balanced mix design is taking performance engineered mixes that next step further, where you are actually balancing out your cracking resistance and your rutting resistance. And finally, lots and lots of study going into self-healing pavements. They're looking at all kinds of different stuff you can add to a pavement that would allow it to heal itself. And we'll be talking a lot more about that in our asphalt paving workshop that I'm going to be teaching a little later this spring. So when we get done with our thin wearing course, this is what we want it to look like. It's a real nice finished product, and in this case, it's a chip seal. Last but not least, I want to talk a little bit about our pre-project meeting. I think this is where it all comes together. You've got to have all the players that are involved, your owner, producer, contractor. You want to be talking about all your aspects of the operation, and you especially want to focus on your QA and QC activities and who's responsible for what. You've got to be emphasizing safety. I don't have to tell you guys, you have to live it every day. And you really want to focus on your construction, doing it the right way. If you're not doing it the right way, you're going to be doing it more than once. You really need a good quality product to be able to get the bang for your buck. You want to be keeping good records, and you also want to be doing some contingency planning. You always want to be prepared because there's always going to be some hiccups. And then finally, you've got to plan the work and work the plan. So we go through in our workshops a bunch of exercises where we will we'll apply our analysis process. We'll marry it up with with the tools in the toolbox. Just walk us through one or two. And if you don't think you're applying pavement management activities within your day-to-day work, but you're doing something like this, you are applying pavement management. So you'll take a set of conditions. This is one of my favorites. You take a look at the distresses, you evaluate the extent and severity, you'll look at your causes. In this case, this pavement's just old. You have a lot of alligator cracking, but that's occurring because the pavement is just been wearing out. There's no loading, there's no drainage issues that you really need to be concerned about. You've got to look at your tools in your toolbox. You look at it on your right-hand side. Do nothing is an option until you've got enough money to be able to do something, because this pavement's going to get worse, but not that much worse. You don't have to worry about drainage maintenance. It's well beyond the ability to do any sort of crack treatments. Patching, you can do that in isolated areas where it's really, really bad. You're probably beyond the point where any thin wearing course is going to help you out. It's not going to last long enough. You're starting to look at your overlays or your thin mill and fills. Recycling is probably not necessary in this case. Deep mill and fill, not necessary in this case, and reclamation, not necessary. So you've narrowed it down, and then you've got to do some cost analysis to decide what your most appropriate treatment. Again, you can do it for any sort of distresses. You can apply that same framework, and we go through a lot of this in the workshop. And last but not least, this is what will we do in this case? Hopefully, we're not having to plow anymore this season. Quick recap. Why do we have roads? Why do we apply pavement management? We want to be able to move our goods and people, and we want to get the best bang for our buck by applying the right treatment, right place, right time, in the right way. We focus on our maintenance treatments because those are the low-cost treatments that are going to allow us to keep our roads in good shape, and it's going to be the most cost-effective strategy that we can apply, because if you wait until that pavement's in poor condition, it's going to cost you 4 to 5 times as much as it would if you were applying maintenance treatments. And our key focus is to address and maintain the safety of our roadways and get the best bang for our buck, protect the public's investment. The tools in the toolbox, we've got our crack repairs, we've got our patching, we've got our thin wearing courses. And in terms of our process, we've gone through that a couple of times. We've got a pretty standardized repair process. The bottom line is our pavement maintenance activities are the most cost-effective way to keep our roads in good shape. You've got a wide range of tools in the toolbox. For maintenance to work, you've got to fix the causes and causes of the distress, not the effects. And the first question to ask, to answer always, how's the drainage? And don't want to forget this, as always, safety first. With that, winding down, got about 5 more minutes left. If anybody's got any questions. Jody,
John,
you got anything in the queue?
we do have one warm mix spec doesn't include a polymer additive to help workability?
Oh, your warm mix has a variety of additives or a variety of processes to create warm mix. And yes, there is a polymer that's also added, which is providing the elasticity. So the warm mix additive allows it to be produced and placed at the lower temperature, and the polymer additive is what's in there that's going to give it its ability to act like a rubber band, gives it a lot more elasticity, and that gives it a lot more longevity. So you're seeing both in your DOT mixes now, you're seeing both the warm mix add, some sort of warm neck mix technology and polymer add. And that's in all your DOT mixes. Anything else?
Nothing yet. I don't
Okay,
see anything.
great. Appreciate everybody spending their time with us today. We've got our workshops, the workshops that are being offered across the state this spring. We're going to be starting up real soon. I've got four of our asphalt paving workshops that are going to be coming up. Take a look at the website. We'd love to have folks join us. And Jody, anything else we need to talk about?
I think that's it. I think we are all set, John. Nice job today.
Thank you, Jody, you as well, and thanks everybody for joining us. Appreciate it and hope to see many of you. The workshops are open and hope to see you there. So thanks, everybody. Have a great day. Enjoy this beautiful spring weather that we've got in the Northeast. Don't want to see any more snow. Thanks, everybody. Have a good day.